SMED, improving retooling processes together. Martin is a member of the production staff and spends a lot of time setting up machinery. After all, between stopping production of the previous item and manufacturing the next product, some preparations are necessary. Customers are increasingly ordering different types of parts in smaller quantities. Therefore, Martin has to set up the machine more and more often. Is there any way to shorten idle time? His colleague Bob tells Martin about the SMED method, which helps him save time during machinery setups. The individual steps for retooling have different efficiency levels. Bob breaks them down into 3 categories: internal, external, and waste. For internal activities, the machine needs to be idle. However, for external activities, the machine can be running. Unnecessary steps, in other words waste, should be prevented entirely. With the SMED method, employees can check organizational and technical processes' efficiency and optimize them. SMED stands for Single Minute Exchange of Die, or to paraphrase, retooling in under 10 minutes. It improves the retooling process in 4 steps: record, analyze, adjust, and transfer. Martin would like to have a SMED workshop with his colleagues as soon as possible, because optimized retooling processes simplify their daily work and promote productivity. When the machine is more flexible and deployable according to customers' needs, it also reduces warehouse stock, and therefore costs. First, Martin needs to know about his current workflow. He needs to record it. After receiving written permission from the Works Council, he makes a video. That way he determines each step of his current approach and can later precisely estimate the retooling processes. Martin's recordings are then analyzed with his colleagues. They do so using special SMED software, outlining the individual steps in a clear format. Then the staff members classify them as internal steps, external steps, or waste. The objective is now to convert as many internal processes as possible into external ones in order to minimize machine idle time. For example, Martin can get the setup cart ready while the machine is still running. Likewise, he can preset the machine tools and take out his hand tools in advance. In the future, we should avoid waste, such as unnecessary walking. Next, the remaining internal steps are technically optimized. For example, painstakingly twisting out screws. Thanks to a new quick-release fitting, Martin only has to loosen the screw instead of unscrewing it all the way. The team comes up with an action plan for concrete optimizations and standards and decides who is responsible for each task. In the adjustment phase, the group implements the action plan, heightening the machine's efficiency, not by working more quickly, but by changing the approach. Finally, the team transfers the results and new standards to other processes and equipment, multiplying the positive impact. By regularly reviewing the improvements, the staff guarantees that the retooling process remains efficient for the long term. As in production, this retooling process can be applied to the assembly shop with lots of optimization possibilities. For example, the staff members can prepare assembly tools and single-piece parts in advance and organize necessary papers before the press is reset. The team can also optimize the remaining internal steps, for instance, using quick lock systems, reduced configuration options, or standardized sorting of tools. It's a real relief for everyone's workday. Even a few minutes of time saved for each retooling can make a big difference over the course of a year. More flexible processes also impress the customers, contributing to Rosenberger's success. SMED, improving retooling processes together.